Hello, algebra students. We're back at it again. This time we're going to be graphing parabolas that are written in what's called vertex form. So let me share my screen and start the presentation. We are starting with kind of a long warm up today. So grab a piece of paper and give this a try. You are asked to do several things here. All right, so first of all, we're given the equation y equals x squared minus 4x plus 3. And you are asked to find the vertex, the equation of the axis of symmetry, tell whether it has a max or min, find the max or min, identify the x-intercepts, we'll talk about that one, and the y-intercept, and then graph it. So pause the video, grab some paper, and give it a try. All right, so hopefully you had a chance to try this. Let's talk first of all about the vertex. Our vertex, remember, we find using negative b over 2a when it's written in standard form. Our a in this case is 1. That's the number that's in front of our x squared term. And our b is a negative 4. So if we do negative b over 2a, we're going to have positive 4 over 2 times 1. So 4 divided by 2 is 2. That's the x coordinate of my vertex. To find the y coordinate, I take 2 and I plug it in place of x here. So I'd have 2 squared minus 4 times 2 plus 3. So 2 squared is 4. 4 times 2 is 8 plus 3. In simplifying that, I get 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. All right, so that's my vertex. The equation for the axis of symmetry, remember, is the same as this x coordinate. So it's x equals 2. To tell whether the graph has a maximum or minimum, I need to know whether it opens up or down. Since our a term here, this 1 in front of the x squared, is positive, this graph opens up and it has a minimum. It asks us to find the max or minimum. The max or min corresponds to the y coordinate. So the minimum is negative 1. All right, y-intercept, remember, if we put 0 in for x, we would be left with 3. So our y-intercept is 3, or you could write that as the ordered pair 0, 3. That's our y-intercept. And we'll talk about our x-intercepts here a minute. This is everything you did in unit 2. So I have y equals x squared minus 4x plus 3. I'm going to take x squared minus 4x plus 3 here. I'm continuing with e. And I am going to factor that. And I'm going to set it equal to 0, right? Because we want to know the x-intercept. So I want to know when y is 0, what are my x values? So I'm going to factor this just like we did in unit 7. I start out with an x and an x. I'm looking for 2 numbers I can multiply to get 3 that add up to 4, and those would be the numbers 3 and 1. Since this is positive, I know these numbers each both have to be negative or both positive. And since my 4 is negative, these are both negative. Next, we use the zero product property to find those x values. So if I write x minus 3 is equal to 0, I'd add 3 to both sides and I get x equals 3. For this factor, I take x minus 1, set it equal to 0. I'd add 1 to both sides of the equation and I get x equals 1. Those are my x-intercepts, 3 and 1. Then it says to graph. Well, I have all kinds of really useful information in this problem now. And I'm just going to draw a little x and y axis. I know my vertex is at 2, negative 1. I know there's an axis of symmetry going through 2. I know the graph has x-intercepts at 3 and 1. So I know there's an x-intercept here at 1. and an x-intercept at 3. So that's 1, 2, 3. Why is that not looking right? 1, 2, oh, because this is 3. Ooh. Right, not that point. That's no. And what else do we know? We knew a y-intercept was 3. And remember, we can find a mirror image on that point. So if I go 2 to the left and 3 up, there must be 1, 2 to the right and up 3. And now I can draw my curve using my axis of symmetry. I know both sides need to look the same. And there's my graph. It has a minimum. It has x-intercepts at 1 and 3. It has a y-intercept at 3. And I used my axis of symmetry to find another point on the graph. All right, today we're going to be looking at quadratics that are written in vertex form. And each form that we're going to look at has its advantage and disadvantage. So when we had that standard form, it was a little tricky to find the vertex. We had to do that negative b over 2a and plug it in every time. If a quadratic equation is written in vertex form, it's really easy to find the vertex and a little more complicated to find things like y-intercepts. So when it's written in vertex form, and we look here, we have this h and this k, that's our vertex, hk. The axis of symmetry is x equals h, just like it was with the vertex in standard form. If the a is greater than 0, the graph opens up, and k is a minimum. If the graph opens down, right, a is negative, then k is a maximum. The graph of f of x equals a times x minus h squared plus k is a translation, h units horizontally and k units vertically. So let's talk about that for a minute. If you remember in the very first lesson we did, we talked about the parent function looks like y equals x squared. When we had numbers at the end, it either shifted the graph up or down. So if I have something like y equals x squared plus 3, that's going to shift the graph up 3 units, 1, 2, 3, and it would open this way. If I have y equals x squared, say, minus 1, that's going to take our parent graph and shift it down 1 unit. So it would be sitting down there. So what this form is going to do is going to take whatever my vertex is, and it's going to shift it h units to the right and k units up. All right. So we're going to add this to our notes on page 263. So if you look in 263 in your journal, way near the top of the page, you have a notes section. Please write down these 3 examples. So pause the video, write them down, and then come back. All right, welcome back. Remember, when our equation is written in vertex form, y equals a times x minus h squared plus k. Remember, when it's written in this form, our vertex is h, comma, k. All right, so let's look at this first one. Right, notice we don't care about this. We're only concerned with this number and this number. So our vertex in this case is 3, 4. All right, super easy to find the vertex in vertex form. We didn't have to do any division or substitution. All right, so notice the standard, or excuse me, vertex form, we have minus h. So this is a plus 1. So when I write the vertex, I need the opposite of that. So it's going to be negative 1. But notice our y coordinate stays exactly as it is. All right, negative 1, negative 2. This time, our vertex is going to be negative 5 and positive 3. I don't know why I'm putting a plus there. Negative 5 and 3. All right, so it's opposite of what's inside here. These numbers are exactly as they are. All right, so this would take a parent graph, shift it 3 to the right and up 4. This makes it upside down. This shifts it 1 to the left and down 2. This moves the parent function vertex 5 to the right, 5 to the left and up 3, And this would make it steeper sides, right? Because those outputs are 2 times as big. All right, practice page 264, graph g of x equals -1/4 x minus 6 plus 4. Find the vertex, the y-intercept, and one additional point on the graph. Let me move my picture out of here. All right, so it's in standard form. Let's talk about finding the vertex. Excuse me, it's in vertex form. So our vertex is 6, 4. All right, easy to find. Our axis of symmetry is the same as the x coordinate of our vertex. So our vertex is, or our axis is x equals 6. Now it's asking us to find one additional point on the graph. All right, a lot of times people like to find the y-intercept. Notice this time, this number out here at the end is not our y-intercept. If we want to find our y-intercept, we'd have to put 0 in for x and solve for y. So we can do that, and actually you could find any point on the graph by putting in a value for x. But I'm going to go ahead and put 0 just because that's pretty easy to work with. I need to do some simplifying here. So let's see, I have -1/4 times. Well, -6 squared is -6 times -6 is a positive 36 plus 4. So I keep simplifying. All right, I have to multiply. Multiplication comes before subtraction. -1/4 times 36, or 1/4 of 36, is -9, because 9 times 4 is 36, plus 4, and I get -5. So I know the y-intercept is the point 0, -5. When I put 0 in for x and solve for y, I get 0, -5. All right, so I'm going to graph some things that I have here. Hopefully I have enough room on this grid to show all of this. We know our vertex is at 6, 4. I didn't leave myself a whole lot of room here. All right, let's see. Vertex 6, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right, this parabola, I know it opens down, so keep that in mind. And it opens down because that a value is negative. I know my y-intercept is 0, -5. So 1, 2, 3, 4, 5, way down here. Remember that there's an axis of symmetry going through this x coordinate of my vertex. And I'm seriously going to run out of room. All right, so I want the mirror image of this point here on the other side of my axis. So if I notice, to get to that point, I'm going 1, 2, 3, 4, 5, 6 units to the left and down 5. So I would need to go 6 to the right, 1, 2, 3, 4, 5, 6, and down 5. And I'm really off the screen, but I think you get the idea. I could also change my scale here. So it said to find one other point on the graph. So we know we went 6 to the left and down 5. If I go 6 to the left or 6 to the right of my axis and down 5, I will be at the point 12, -5. All right, and that's the mirror image on the other side of this axis. So find the vertex, check. Find the y-intercept, check. Find one other point on the graph, check. All right, let's look at our next slide, which is the assignment. So again, we have some more fun parabolas in the real world. This is in your book, page 446. You'll find the link to the book pages in Schoology, along with some more examples if you want to check those out. If you have any questions, send me an email. So good luck.